Hello everyone, I'm going to go over section 11.3 today concerning geometric sequences. You may remember that an arithmetic sequence is one that goes up by the same amount every time or goes down by the same amount every time. We say it has a common difference. With geometric sequences, instead of going up by a fixed amount, it goes up by a fixed ratio or down by a fixed ratio. So if you divide any two successive terms, you'll get the same number every time. Okay, and that number we call R. So the R is what's known as the common ratio, and then you can see in this formula here, A1 is the first term, A sub n is the nth term. So here we have given an A1 of a first term and a common ratio of 2. We can write out the first 5 terms of the sequence. The first term is 5 that's given to us, so that's pretty easy. Then to get the second term, we just multiply by 2. So that would give us 10, and then multiply by 2 again, multiply by 2 again, multiply by 2 again. So 5, 10, 20, 40, 80 would be the first 5 terms of this geometric sequence. All right, so on this one, we probably, if we have to find the 12th sequence given the first 3, we probably don't want to have to write out all 12 terms if we can find a shorter way to do that, right? So using that formula, the formula for the nth term, a sub n is a sub 1 r to the n minus 1, we already know what a1 is because all we have to do is look at the first term, and you've probably already figured out what r is, right? 5 times 3 would give you 15, and 15 times 3 would give you 45. So our common ratio is 3. So we plug those pieces in, and we'll be able to find out that A12 is 5 times 3 to the 11th. 3 to the 11th is 177,147, and then you multiply that by 5, and you get 885,735. So let me back up for just a second and point out one common mistake that I see here. I will occasionally have students work this part of the problem in the wrong order. Okay, remember, your order of operations says that you have to do exponents before you can do multiplication. So, however, despite that, sometimes I do see students that will do 5 times 3 and then raise that to the 11th power, but that is a mistake. So just be careful of that. It's not that I don't think students in honors pre-calc don't know that rule. You just kind of maybe get going too fast and overlook it. So 3 to the 11th first, then multiply by 5. So we get 885,735 for our 12th term. Now we can also write these geometric formulas as recursive formulas, but this almost seems too easy to me because basically it's just, because you're multiplying, it's just going to be the previous term times r. That the nth term is always the previous term times r. So I went ahead and even do the animations here on this example, write a recursive formula for this sequence. So our first term is 6. Remember, all recursive sequences or recursive formulas have to provide that first term. So make note of the first term and then figure out what you're multiplying by. So in this case, doing 9 divided by 6, we get 1.5 for the common ratio. Or you could simplify it to 3 halves if you'd rather do the fraction. And then our recursive formula just becomes A1 is 6, and then the nth term is 1.5 times the nth, n minus 1 term. So recursive formulas are super easy, both for arithmetic and for geometric sequences, I think. And I think you probably see why. Well, I kind of gave away the answer here, messed up my animations, but we want to find the number of terms in a sequence. And in this case, our first term is -1 and our final term is 2187. So pointing out some of the important relevant information here, you might notice that the first term is -1 and the common ratio is -3. However, I'm going to give you a tip here on this kind of alternating sequence like this that goes back and forth between negative and positive. If all you're trying to figure out is the number of terms in the sequence, I would completely ignore the negatives. Okay, pretend like the first term is actually +1 and the common ratio is +3. And the reason for that is we're going to have to use a logarithm to solve for the number of terms in the sequence, and you don't want to try to deal with a logarithm that has a negative base. Okay, I don't know if you recall from several chapters ago when we talked about those, But we always said that the base of a log needed to be positive, and we'd like to stick to that rule. So, and that's because we want to stick with real numbers, right? I mean, we know that there's a real number that is the answer to this. Actually, you already know that it's 8 because I accidentally showed it to you. But we don't want to deal with imaginary numbers, so we're not going to have we're not going to have negative bases on our logs. So we're going to pretend everything's positive. It's not going to change the number of terms if we just say that everything's positive. So since that's all we're looking for, we can ignore the negatives. So our last term is 2187. That's the nth term. And then our first term is 1. Our common ratio is now 3. And then remember that that formula for the nth term was a1 times r to the n minus 1. So that's what we have here on the right-hand side. So now I take the log base 3 of both sides because I'm trying to get rid of the 3 on the right and just have the n minus 1. So I take the log base 3 of both sides. Evaluating log base 3 of 2187 gives us 7. And then on the right-hand side, the log base 3 of 3 goes away. It cancels out, and you get n minus 1. Add 1 to both sides, and that's how we got 8. So there are 8 terms in that geometric sequence. So I thought that was an interesting example where the sequence actually has some negative numbers in it, but dealing with the negatives is actually detrimental. And in this case, it doesn't affect the number of terms in the sequence. So just a little tip there. If you have some negatives, sometimes it's best to just ignore them until just to achieve your goal. All right, so here is a set of homework problems that I think will be helpful in getting you acclimated with geometric sequences. And we'll do a Zoom meeting next time to discuss this if you got any questions or anything. And I'll talk to you then. Thanks.